Stephen Hawking spent his entire life trying to solve one of the biggest mysteries in science. What exists beyond the edge of everything we can see? This question kept him awake at night, drove his research, and led to discoveries that changed how we think about reality itself. The answer he found is both beautiful and terrifying. Before we dive deeper into this incredible journey, I want to ask you something. Where are you watching this video from right now? Drop a comment below and let me know your city or country. I love connecting with viewers from around the world. And if you find this fascinating, please hit that like button and subscribe for more amazing discoveries about our universe. The observable universe is like a giant bubble around us. We can see about 93 billion light-years in every direction. That might sound enormous, but Hawking believed this was just a tiny fraction of what actually exists. Imagine standing in the middle of a vast ocean at night, holding a flashlight. The circle of light around you is all you can see, but the ocean continues far beyond that circle. Our universe works the same way. Hawking realized that light from distant galaxies takes time to reach us. The farther away something is, the longer its light takes to travel to Earth. This creates a natural boundary to what we can observe. Beyond this boundary lies the unobservable universe, and this is where things get really interesting. In the 1980s, Hawking worked with other scientists to develop a theory called cosmic inflation. This theory suggests that right after the Big Bang, the universe expanded faster than the speed of light for a brief moment. During this expansion, tiny quantum fluctuations got stretched out to massive scales. Think of it like blowing up a balloon with small wrinkles on its surface. As the balloon expands, those wrinkles become much larger. These quantum fluctuations became the seeds for galaxies, stars, and everything we see today. But here's the remarkable part. If inflation happened the way Hawking described, then our observable universe is just one small region in a much larger space. Beyond our view, there could be countless other regions, each with their own galaxies, stars, and perhaps even life. Hawking spent years calculating what these other regions might look like. He discovered that they don't all have to be the same as ours. The laws of physics might be different in some areas. Gravity could be stronger or weaker. The forces that hold atoms together might work differently. Some regions might be completely empty, while others could be filled with exotic forms of matter we can't even imagine. This led Hawking to a startling conclusion. If the unobservable universe is truly infinite, then every possible arrangement of matter and energy must exist somewhere. This means there could be exact copies of you living in distant regions beyond our view. There could be versions of Earth where history unfolded differently, where dinosaurs never went extinct, or where humans developed completely different technologies. But Hawking wasn't satisfied with just theoretical possibilities. He wanted to find ways to test these ideas. He realized that even though we can't see beyond our observable boundary, we might still find evidence of what lies beyond. The key is to look for patterns in the cosmic microwave background radiation. This radiation is like the afterglow of the Big Bang, and it fills the entire universe. Hawking suggested that if other regions of space had influenced our area during the early moments after the Big Bang, they might have left subtle imprints in this background radiation. These imprints would be incredibly faint, like whispers from beyond the edge of everything we can see. Scientists have been searching for these whispers using powerful telescopes and satellites. Some researchers claim to have found unusual patterns that could be evidence of other universes bumping into ours billions of years ago. However, the scientific community remains divided on whether these patterns are real signals or just random noise in the data. Hawking also explored another possibility. What if the universe has multiple dimensions beyond the three we experience every day? String theory, a branch of physics that Hawking contributed to, suggests that reality might have 10 or 11 dimensions. Most of these extra dimensions would be curled up so small that we can't detect them directly. But in these higher dimensions, our entire observable universe might be like a thin membrane floating in a vast space. Other membranes could exist nearby, each containing their own universes with different properties. These parallel universes could be just a tiny distance away from us in the extra dimensions, yet completely unreachable using ordinary matter and energy. Hawking worked on equations that describe how these membrane universes might interact. He found that, under certain conditions, they could collide with each other, creating new Big Bangs and new universes. This process could have been happening for eternity, with an endless cycle of universe creation and destruction playing out in dimensions we can't perceive. The implications of this work are staggering. If Hawking was correct, then the Big Bang that created our universe wasn't a unique event. It was just one collision among countless others in a cosmic dance that has been going on forever. Our entire history, from the first stars to the evolution of life on Earth, represents just one brief moment in an eternal process. This raises profound questions about the nature of existence itself. If there are infinite universes with infinite possibilities, what makes our particular universe special? Hawking grappled with this question throughout his career. He suggested that we observe the universe we do because it's the only one capable of producing conscious observers like ourselves. This idea, known as the anthropic principle, states that the universe appears fine-tuned for life because we can only exist in universes that allow life to develop. In regions where the physics is different, where stars can't form or atoms can't exist, there would be no one around to observe anything. We see what we see because we're here to see it. But Hawking wasn't completely satisfied with this explanation. He felt it was too much like giving up on finding a deeper reason for why our universe has the properties it does. He continued searching for more fundamental explanations, ones that might predict the exact values of physical constants without relying on the anthropic principle. This search led him to some of his most ambitious work. Hawking began exploring the possibility that the universe might be self-creating. Using advanced mathematics and quantum mechanics, he developed models where the universe could bring itself into existence without needing any external cause or creator. In these models, the boundary between existence and non-existence becomes blurred. The universe doesn't have a definite beginning in time, but rather emerges from a quantum state that contains all possibilities. Space and time themselves arise from this quantum foam, creating the stage on which all of physics plays out. Hawking compared this to the surface of the Earth. If you travel south from the North Pole, you eventually reach the South Pole and can't go any further south. Similarly, if you travel backward in time from the present, you eventually reach the beginning of time and can't go any further back. But just as the North Pole is a perfectly ordinary point on Earth's surface, the beginning of time might be a perfectly natural feature of the universe's geometry. This work suggested that the question, what caused the Big Bang, might be meaningless, like asking what's north of the North Pole. The universe could be completely self-contained, with no need for anything outside itself to explain its existence. As Hawking aged and his physical condition deteriorated, he became even more focused on these ultimate questions. He realized that understanding what lies beyond our observable universe might be the key to understanding why anything exists at all. He worked tirelessly to develop a theory of everything that would unite quantum mechanics with general relativity and explain the deepest mysteries of existence. One of his final contributions involved the concept of holography in physics. Hawking helped develop the idea that all the information in a volume of space can be encoded on its boundary, like a hologram. This suggests that our three-dimensional reality might actually be a projection from information stored on a two-dimensional surface. If this is true, then the boundary of our observable universe might contain all the information about what lies beyond. We might be able to decode this information and learn about the unobservable regions without ever traveling there. It's like being able to understand an entire book by examining just its cover, if you know the right way to read the encoded information. Hawking's exploration of black holes also provided insights into the nature of the unobservable universe. He discovered that black holes emit radiation and eventually evaporate completely. This process, known as Hawking radiation, suggests that information can never be truly destroyed, even when it falls into a black hole. This principle might apply to the entire universe. If our cosmic region eventually collapses or experiences heat death, the information it contains might not disappear. Instead, it could be preserved in some form, perhaps encoding itself onto the boundary of space-time or transferring to other regions of the larger multiverse. The mathematics behind these ideas is incredibly complex, but the basic concept is surprisingly simple. Everything that happens in our universe, every thought you've ever had, every star that's ever formed, creates information. This information might be eternal, existing in forms and places we can't currently comprehend. Hawking also considered the possibility that consciousness itself might play a fundamental role in the structure of reality. Some interpretations of quantum mechanics suggest that the act of observation causes quantum possibilities to collapse into definite realities. If this is true, then conscious beings like ourselves might be actively participating in the creation of the universe we observe. This doesn't mean we're creating reality through our thoughts, but rather that the process of observation and measurement might be built into the fundamental fabric of space-time. The universe might require observers to fully exist, creating a deep connection between mind and matter that goes beyond anything we currently understand. These ideas pushed Hawking to consider whether artificial intelligence might someday develop the ability to observe and understand aspects of reality that are currently beyond human comprehension. He speculated that advanced AI systems might be able to process information from the cosmic microwave background radiation or detect patterns in quantum fluctuations that reveal hidden features of the unobservable universe. But Hawking also warned about the potential dangers of creating artificial intelligences that surpass human capabilities. He worried that such systems might discover aspects of reality that fundamentally change the nature of existence itself, possibly in ways that could be harmful to humanity. Despite these concerns, Hawking remained optimistic about humanity's future and our ability to understand the deepest mysteries of existence. He believed that the human drive to explore and discover would eventually lead us to a complete understanding of reality, including what lies beyond the observable universe. His work has inspired a new generation of physicists and cosmologists to continue this quest. They're developing more sophisticated theories, building more powerful telescopes, and designing new experiments to test ideas about the nature of the unobservable universe. Some researchers are working on ways to detect gravitational waves from the early universe, which might carry information about cosmic inflation and the larger structure of space-time. Others are studying the quantum properties of space itself, looking for signs that our reality might be emerging from a deeper, more fundamental level of existence. The implications of this research extend far beyond academic physics. If Hawking was correct about the nature of the unobservable universe, it could fundamentally change how we think about our place in reality. We might be just one small part of an infinite tapestry of existence, with countless other forms of life and consciousness existing in regions we can never directly observe. This perspective can be both humbling and empowering. It suggests that the universe is far stranger and more wonderful than we ever imagined, filled with possibilities we can barely comprehend. At the same time, it demonstrates the incredible power of human intelligence and curiosity to uncover truths about reality that seem impossible to discover. Hawking's legacy lives on in the questions he asked and the tools he developed to answer them. Every time we look at the night sky, we're seeing the boundary between the known and unknown, between what we can observe and what might exist beyond. Thanks to his work, we now have mathematical frameworks and theoretical tools that might eventually allow us to peer beyond this boundary and understand the true nature of everything that exists. The secret of what lies beyond the observable universe remains one of the greatest mysteries in science. But thanks to Stephen Hawking's brilliant mind and tireless dedication, we're closer than ever to solving it. His work reminds us that the universe is not just stranger than we imagine, but stranger than we can imagine. And that's what makes the journey of discovery so exciting. The questions Hawking raised about the unobservable universe touch on the deepest philosophical issues humans have ever contemplated. What is the nature of existence? Why is there something rather than nothing? Are we alone in the vastness of space and time? His scientific approach to these ancient questions has opened new pathways for understanding reality itself. Modern experiments continue to test Hawking's ideas about cosmic inflation, parallel universes, and the holographic nature of reality. While we haven't yet found definitive proof of what lies beyond our observable boundary, the search itself has led to remarkable discoveries about the nature of space, time, and matter. The technology we've developed to explore these questions has practical applications that benefit humanity in countless ways. GPS satellites must account for the effects of general relativity that Hawking studied. Medical imaging techniques use principles from quantum mechanics and field theory, Computer processors rely on our understanding of quantum tunneling and electron behavior in materials. But perhaps the most important legacy of Hawking's work is the sense of wonder and curiosity it inspires. He showed us that the universe is far more mysterious and beautiful than we ever suspected. Even the most abstract mathematical concepts can reveal profound truths about the nature of existence. His approach to science was characterized by bold thinking and creative imagination, combined with rigorous mathematical analysis. He wasn't afraid to consider seemingly impossible ideas if they might lead to deeper understanding. This combination of creativity and precision is essential for tackling the biggest questions about reality. The story of Stephen Hawking's quest to understand what lies beyond the observable universe is really a story about the power of human curiosity and intelligence. Despite facing tremendous physical challenges, he never stopped asking questions and seeking answers. His work reminds us that the pursuit of knowledge and understanding is one of humanity's greatest achievements. As we continue to explore these cosmic mysteries, we carry forward Hawking's spirit of inquiry and wonder. The universe may be vast and strange beyond our current comprehension, but the human mind has proven capable of remarkable insights into its deepest secrets. What we discover next might surprise us all. The boundary of the observable universe represents the current limit of human knowledge about the cosmos. But as Hawking showed us, boundaries are meant to be crossed, limits are meant to be transcended, and mysteries are meant to be solved. The greatest discoveries about what lies beyond our cosmic horizon may still be waiting for us to uncover them. Thank you for joining me on this incredible journey through Stephen Hawking's insights into the deepest mysteries of existence. If this exploration has sparked your curiosity about the universe, please give this video a like and subscribe to the channel for more fascinating discoveries about the cosmos. The universe is full of wonders waiting to be explored, and together we can continue the quest that Stephen Hawking began.